extreme weather happens all over the place. It happens without much warning, and sometimes the events are pretty short-lived. From NASA's standpoint, one of the most difficult problems we face is diagnosing extreme weather. The idea that we're going to chase a storm with a satellite to take measurements, or chase a storm on the ground with some type of, ground-based sensor is kind of silly. So the dream for us is if we can get these radiometers and spectrometers small enough to fit on these small spacecraft, we can fly giant constellations. So wherever the storm pops up, we already have the sensors there. And then we can understand how these things form a lot better and start helping to predict them in the future. My name's Adrian. I'm from the Jet Propulsion Lab in Pasadena, California, and I work in the sub-millimeter wave group. And what we're focused on is building remote sensing instruments that, whether we're measuring, distant galaxies for astrophysics, or we're doing planetary science on the surface of Mars, looking at atmospheres, or here on Earth, looking at climate science. We build the instruments that do that. So we build everything from radar systems to spectrometers to radiometers that look at extreme weather events and how moisture is distributed. And my group really builds most of the electronics for all these instruments. The paper I'm presenting at SPIE, Defense and Commercial Sensing, is a very compact radiometer system. One of the things that we are interested in at NASA is making things cheaper because budget is difficult. So what we do is we're looking at cellular phone technology, CMOS technology, to implement more and more of our instruments. And this has a couple of advantages. One is it makes the instrument cheaper, but it also makes the instrument a lot lower power and a lot smaller. So then we can fly them on cheaper platforms like a small cube satellite or maybe a UAV, not necessarily the gigantic, multi-million-dollar space mission anymore, while still doing the same level of science. Other things this might be useful for are security screening, possibly autonomous cars, anything that needs millimeter wave or microwave sensors that are relatively small and low cost. So the real challenge in using CMOS technology to build radiometers and atmospheric sensors is that it's typically not sensitive enough. So the cell phone signal from the tower is a very short range, a couple of 100 meters. The signal's very strong, it's very easy, it works great for the cell phone. When you get into space sensing, the signal levels that you get, or the radar reflections you get, are much, much lower power. So the signal's much weaker, it's very hard to see. Sensitivity becomes a major problem. So we use a lot of different techniques that you wouldn't normally use in circuits to overcome those sensitivity limitations and get you the measurements that tell you about clouds and about atmospheric moisture and all the hydrology cycle. And the paper that I'm presenting at SPIE, Defense and Commercial Sensing, is on those techniques. I think it's really, really interesting if we can use the commercial technology to break into the remote sensing business, because there's really been a stagnation in the technology over the last 20 years. NASA tends to fly instruments that have a long heritage, and this short timeline, rapid infusing and rapid development is a whole new area for the agency. My research goals are to just continue to support NASA missions, and give NASA options of new and lower power sensors, and give them new ways to sense their environment or environments on other planets, and hopefully contribute to the science, which is really our core mission, through development of our instruments. Often we're so tuned into mission planning or infusing the instrument into a flight, we don't appreciate the larger picture of what we've accomplished actually bringing the stuff from the commercial world into the remote sensing world. My work in general, is focused on extreme weather and predicting extreme weather. And extreme weather kills an awful lot of people in the continental US. So if you can figure out how to forecast these storms and give people 15 minutes, 20 minutes, an hour more warning, that will save an awful lot of lives. And that's what really drives the work that we're doing.